Okay, so we're going to have a look at another question from the topic of advanced mechanics. We're told two space objects are launched from Earth. One has mass m and the other has mass 2m. We're asked which has a larger escape velocity. Alright, so when we have a look at part A, we need our escape velocity formula. So the escape velocity is equal to the square root of 2 times gravitational value multiplied by the large object mass divided by the distance. Now you'll notice this function is not a function of the mass of the objects being launched. So this is only a function of the distance and the mass of the main object, so in this case the mass of the Earth. So velocity escape of the first object is actually equal to velocity escape of the second object in this case. So which one has a larger escape velocity? They both have the same escape velocity, because escape velocity is not a function of their mass. So that's part A. Now if we have a look at part B, we're asked which has more kinetic energy at launch. Well, we know kinetic energy is 1/2 times mass times velocity squared. This means we get two separate kinetic energies. We get kinetic energy of the first object is 1/2 mv escape squared, and kinetic energy of the larger one is 1/2 times 2m times v escape squared. The 1/2 and the 2 cancel. This is m v escape squared. So here, kinetic energy 2 is greater than kinetic energy 1. So which has more kinetic energy at launch? The more massive one. And this makes sense because they're going at the same speed. Kinetic energy is a function of mass and velocity. Given that their velocity components are the same, the only other thing that will affect the kinetic energy is the mass. The one that has twice as much mass should have twice as much kinetic energy, and that's what we're seeing here. So this is the answer to this question about escape velocities and kinetic energies at launch.